right, hello everybody, and welcome to the seminar series. It's my honor to be the host of this week's session. Today, we have a wonderful guest, Dr. Gianluca Strin. He is an assistant professor in the ECE department at Boston University. Gianluca works in the area of data-driven security, analyzing large data set to better understand complex malicious online operations and developing mitigation techniques to find them. So he received multiple prizes, including an NSF Career Award in 2020. And his research won multiple Best Paper Awards, including one at IMC 2018. So he has published over 100 peer-reviewed papers, including several in the top security conferences such as SMP, CCS, NDSS, and Usenix security, as well as top measurement and web conferences such as IMC, ICWSM, and Dr. Strin, welcome again to our weekly seminar, and thanks for accepting our invitation. The floor is yours.
Yeah, sure. Thanks. Thanks everybody for having me, virtually today. So today I will tell you about part of my research, which focuses on modeling, measuring, and mitigating what I call weaponized online information, which I will tell you what I mean by that in a moment. So my background is in computer security, and much of my research is actually on more traditional computer security. So malware detection, spam detection, botnet detection, and so on and so forth. I talk about these topics as the good old times to some extent, because although they're not easy topics, they are inherently adversarial, and it's not easy to comprehensively protect against malware and whatnot. But at least as researchers, we know where we stand. We know, who the bad guys are, who the good guys are, and what we should do to prevent this kind of attacks, at least ideally. More recently, newer and more vicious types of online abuse have emerged. And in particular, we've seen coordinated online harassment campaigns on social media targeting celebrities or various people. We've seen other types of personalized attacks, as well as disinformation, conspiracy theories, and so on. And some of these things even led to real-world violence. So this is what I call weaponized online information. So these are online operations carried out by humans, so they're not bots. And they have various goals, basically to cause harm, which can be attacking people through online hate, so bullying, harassment, doxing, and so on and so forth, as well as disinformation. So, misleading information online that can lead to, less than optimal activities or human actions. Think about COVID-19 disinformation and so on, as well as propaganda, election meddling, and so on and so forth. Now, for this new type of malicious activities, the research community doesn't really have good computational tools to properly understand them, measure them. And understanding them and measuring them is actually the first step to actually come up with mitigations. So in my research, I try to do this. So together with my group, we develop approaches to automatically measure, model, and trace online weaponized information. And these approaches can be used to identify emerging information campaigns, weaponized information campaigns, identify influential actors, and identify influential communities. And once we do that, we can think about what to do about them. And I will also tell you that, later in the talk, that maybe the mitigations that we've been using in computer security so far, which are basically just, deleting bad content and suspending bad actors, may not be the most effective ways to deal with these issues. So what are the research challenges here when we look at these emerging types of online abuse. Well, the first one, since most of what I do is data-driven, is collecting data. We are talking about operations that are carried out on social networks or various types of online services. The challenge is collecting enough data and quickly enough and analyze it quick enough to actually understand what's going on. So there are many social networks, each with their own characteristics. And my group and I have been collecting many of them. We have billions and billions of posts, but information is also visual. So we also need to make sense of images, for instance. So we're also collecting that. And if you're thinking about disinformation campaigns, they're not only carried out on social media, but they're also carried out on news websites. So we need to be able to collect news articles and being able to treat them in context with how are they discussed on social media, and so on and so forth. And then we can get to videos as well. So we need to make sure to make sense of what is being said in videos at scale. So there are massive computational challenges here. Another big challenge is that this weaponized content is not algorithmically generated. So when I was dealing with Twitter spam, 10 plus years ago, I could develop techniques that could identify content that was either exactly the same or was generated by the same algorithm. So it had the same characteristics. When we talk about online hate, that's not necessarily the case. We actually have real people attacking online users and just posting content manually. Also, a lot of the research that the computer security community has carried out in the past was dealing with this large-scale automated bot activity. So a cyber criminal would press a button and suddenly hundreds of thousands of infected computers would carry out some activity, send spam, perform a denial of service attack, or whatever. And so when we develop systems to detect that kind of activity, we can leverage the fact that it's large scale and that it's synchronized. And there are many systems, some by my group and some by other people. SynchroTrap is how Facebook detects fake activity. The idea is that many accounts controlled by the same person will roughly, carry out activities at the same time in a synchronized fashion. When we talk about human activity, this is less coordinated. So these characteristic traits stand out less. But we still have some loose synchronization. So they organize a campaign, they decide to go and attack a person, as I will show you in a bit. They may have common talking points, so we can still maybe leverage this information to detect. Also, there is a blurred line. So, these are humans, but oftentimes they're also using fake accounts. So a single person may control a small army of accounts and post this content at the same time. And here are some calls for attacks asking to, create fake accounts and go attack journalists and whatnot, and so on. Also, as I said, information is not only textual. And actually, a lot of malicious weaponized information these days is carried out through images. Think about viral memes that might have, some hidden meanings. Or even videos. So we've seen, terrorists actually post their manifestos online in some of these communities that are also involved in spreading conspiracy theories, etc. The biggest challenge probably is that the web is a complex ecosystem and online services do not exist in a vacuum. So virtually all research that studies malicious activity online of any kind looks at a single service at a time. Typically Twitter, because it's easier to get data. But we have papers that look at other systems. But actually, if you think about how you use social media, you probably have accounts on multiple social media. And maybe you see information on one of them and you post it on a second one. Maybe people organizing these malicious aggression campaigns will organize on a platform and then go and target someone on another platform. Not only that, but when you post a link on social media, that link resides on a different platform. And the different platform might allow people to interact with it as well. So they could post comments, for example, they could like, dislike, and so on and so forth. So we need to develop techniques that take this into account, that can trace information across media, with each service having different semantics, different ways of operating, and so on and so forth. And once we detect this information, what do we do? As I told you, in computer security, we are used to just delete content, suspending accounts, or there is this idea that we create mitigations that raise the cost for attackers. So it will be more expensive for attackers to operate. Think about spam. You know, if they have to slow down sending spam, they will send less spam, and so it will cost them more, or at least, you know, they will make less money. This is not necessarily the right solution against weaponized information. If we suspend users, they may move to less moderated and controlled platforms, and these might have some side effects, which I will tell you about later. Also, if you are thinking about disinformation campaigns and state-sponsored disinformation campaigns in particular, you know, a foreign adversary might not care about how much does it cost them to carry out a disinformation campaign. And then there are also some, you know, free speech considerations that, you know, you may have seen in the recent debate. So we wrote a paper that will be published at Auckland later this year to sort of sketch this research landscape and thinking about how can security researchers help and what applies and what doesn't apply of what we've been doing for many years in this space. So now I want to give you a couple of examples of topics that I've been working on in this space. And the first one is what I call online raids. And to begin, I'll give you an example of something that happened to me. So one day I was sitting in my office and I started receiving weird emails that, you know, didn't make any sense. So at first somebody wrote to me saying that the recent election shocked them. This was 2017, so it was the previous presidential election. They were shocked by all the, you know, racist rhetoric and so on and so forth. They were asking me, what can they do about it? Shortly afterwards, I received another email by a student asking me for advice about a class project from a community studies class that I had never heard about. And then, you know, actual threats started arriving and, you know, this went on for a while. So what was happening there? I later discovered that somebody posted this screenshot on 4chan's politically incorrect board, which is one of these polarized communities that I will discuss later. And this is an assignment from a college class, this community studies project that the supposed student was asking me about, where the professor was asking students to go on this platform and post about you know, gender issues, women's rights, Marxism, and whatnot. And this is a community that's very much, you know, it very much belongs to a so-called alt-right. So they didn't like this. And if you look at the bottom, the email address of the professor is actually censored, but they interpolated that, that email address and they got convinced that it was me. So they started talking about attacking me, and, you know, they doxed me, they posted all details about my online presence, they called for an attack against me, and then they started posting templates of emails to send me. And if you look at this one, it's exactly the one that I received later. So this went on for a while, and you can see how people were coordinating on this platform to attack me in this case. And then we would come back and comment on it, so we could see how there was an aggregation point and an attack surface that was actually on a different platform. Eventually, they got convinced that it wasn't me, and in fact, it wasn't me, and so the attack stopped. But this is an example of what we call a raid. So a coordinated aggression attack orchestrated by a community against another community or an individual. So we decided to study this problem. And to study this problem, we focused on 4chan, because that attack in particular happened there, but also this community is somewhat infamous for organizing this kind of attacks. These are the people that when Microsoft put the Taybot online, but it was this chatbot that was supposed to learn from its users, they turned it racist in a few hours, okay? So what is 4chan? 4chan is an image board where people can post an image and some text, and this starts a thread and people can talk about it. But it's quite different from social media as we are used to, because there are no accounts, so whoever posts there does it anonymously. And also threads are ephemeral. So there can only be a certain number of threads active at the same time. And if you create a new one, the bottom one, the least popular one, gets frozen, it gets put in an archive, and then it disappears after a week. And threads, the median lifetime of these threads is 47 minutes from what we've observed. So as you can imagine, anonymity and ephemerality generates or facilitates all sorts of bad behavior online. So we'll be studying this community, and in particular, the politically incorrect board on 4chan, where a lot of this bad activity has been going on for a while. And we've actually recently released a data set containing all the posts that we were able to collect. It is over 100 million posts over a period of 3.5 years. So it is much smaller than Twitter or Reddit or Facebook. But as we will show in a bit, it actually has a lot of influence on malicious online activity of all sorts. So what is the threat that we are studying? As I said, there is an attacker posting a thread on 4chan or a similar platform with information about a victim, which we call an organization thread. And other people on the platform will participate, will join, and will post more information about the victim, will go and attack the victim on all sorts of platforms. So it can be Twitter, YouTube, email, as in my case, and so on. And then we'll come back and report on the thread. So the first time we studied this, we focused on YouTube videos because we observed that oftentimes attacks targeted YouTube videos. So somebody would post a YouTube video about some topic that people on that platform didn't like, and people would call for an attack against that person. And we wanted to understand, how does posting a video on this politically incorrect board influence the commenting activity on the video? Because that's the way in which attackers would actually abuse the platform. And we found that once a YouTube video was posted on 4chan, we would see a spike in the comments on the YouTube video. If you remember, 4chan threads are ephemeral, and so we can see, we can basically build buckets, epochs, if you like, and consider the comments appearing during the lifetime of a thread, and then the comments appearing 1+ the lifetime of a thread, and 3+, and so on and so forth. So we see that while the video is alive, or shortly after, while the thread is alive, or shortly after it's dead, we see a peak in commenting activity. That is interesting, but it's not what we are looking for, because that's the purpose of any social media. If you post something online, you expect that people will interact with it. So we developed a different metric. What we did, we leveraged the fact that there is this aggregation thread. Yeah, so sure. Yeah. Is it a question or is it No, okay, I'll continue. So we leverage this idea that we have an aggregation thread on 4chan, and we have comments on YouTube. And we can model these two as basically signals, as a sequence of timestamps. And then we can look at how synchronized they are. The idea is that people will interact on 4chan, will go on YouTube, post a comment, and maybe come back. And ideally, this would happen instantaneously, perfect synchronization. In practice, we don't expect that. But on the other hand, we expect that if the synchronization is very, very loose, it is very unlikely that an attack is happening. So to this end, we use cross-correlation, which is a signal processing metric. And we calculate this cross-correlation between the two signals. And this is useful because it gives us a number to reason about. Each aggregation thread now has a number that tells us how synchronized are the comments on 4chan compared to the comments on YouTube. And then we used a hate speech API, the hate-based API, to plot on the x-axis the amount of hateful comments that the thread would receive per second in this case. And as you can see, the closer the synchronization, the more synchronized the comments on 4chan and the comments on YouTube are, the higher the hate speech. So suddenly we have a metric that allows us to identify YouTube videos that are being attacked. And this is useful for a number of reasons. The way we used it was to identify a ground truth of YouTube videos that received hate. And then we used these YouTube videos to understand what are the characteristics of these YouTube videos that tell them apart from videos that did not get rated. And can we actually use that to inform moderation? So what we did in a follow-up work, we analyzed these videos across a number of axes. So we look at the metadata of a video, the title, the category, and so on. We apply image processing to the thumbnail that's being shown as a preview of the video. And then we also extract the transcript of the video to figure out if certain topics are more likely to be attacked and so on. And then we train an ensemble classifier that basically tells us how likely is it that this video will be rated in the future or not. And this works very well. So we have an AUC of 0.94. The way we expect to use this is for moderators like YouTube moderators to actually establish a risk score of a video so that they can focus on videos that are risky and maybe not focus as much on the ones that have a very low risk. This is motivated by the fact that human moderators are actually overwhelmed by the amount of videos that are posted. And so they cannot keep up with the attacks that are actually happening online. More recently, we looked at a related issue, which is the one of Zoom bombing. So the threat is quite similar to what I discussed, except that this time an attacker will post a link to a Zoom or another online meeting platform on 4chan or another platform, and ask people to go and disrupt that meeting. And so they will join, they will annotate the screen, they will shout profanities, all sorts of things, post in the chat and so on. So this, of course, raised to prominence during the COVID-19 pandemic, when all our activity switched online. So we wanted to understand to what extent does it happen, and who are the attackers, and what do attacks look like? So what did we do? We identified 10 popular meeting services, so Zoom, Google Meet, Google Hangouts, Cisco WebEx, and so on and so forth. And then we went and looked on 4chan for all the posts containing those links. And we also looked on Twitter for all those posts containing those links. And then we had students actually manually annotate these posts to figure out, is that a Zoom bombing call or not? And then we analyzed what we found. And what we found was quite interesting. So we found that the vast majority of these attacks target online classes. So these would be high school classes or college classes, which makes sense because we started looking at the problem early 2020. And in March, basically, all lectures went online. Probably the most surprising finding is that 70% of these calls are called by insiders. So these are students in the class, typically, who are bored and they ask strangers to join and disrupt their class. And we also find that pretty much all of them happen in real time. So they're not planned ahead of time. So a student will post a link saying, you know, my class is happening right now. Please come and disrupt it. So this is interesting, and you know, I encourage you to go and read our paper if you want more details. But from the security point of view, the most interesting aspect is this insider aspect. So if you think about how Zoom bombing prevention works, typically, at least the advice that was posted in the past year, they tell you to adopt a password. They tell you to create a waiting room so that you can screen who's allowed in and who's not. But actually, if the attacker is an insider, they can provide the password to attackers. And actually, we see that happen. We also see attackers telling people which names to adopt who, you know, belong to real students in the class, so that the teacher or the professor will be confused and won't be able to screen who's legitimate and who's not. So the way this could be prevented is by enforcing basically one-time unique links. So this meeting actually checks that whoever is joining is logged in with the same email that received an invite. So that's good. It's an option that Zoom provides, but not all the meeting platforms provide the same mitigation. So also, I believe it's only a paid feature. I don't think it's available in the free version. But anyways, we need to start thinking that these attackers might actually come from the inside and not from the outside. Are there any questions so far? No? Okay, then I'll move to the second topic.
I have a question. For these attackers that are like harming people, why do they, like, for the ones that are harming people, like in your case that are like false people, why don't they I guess check if the person they're attacking is actually the person they want to attack, or how can we stop these people?
Yeah, I mean, I guess that has to do with a lot of online culture. So, you know, people are quite impulsive. So they would just jump to conclusions and go and attack somebody. That's a big problem. You know, I was watching a documentary on Netflix yesterday, and there was this case of, you know, this girl who died in a hotel in LA, and people online were trying to solve a mystery, and they got convinced that somebody was the murderer and that person had nothing to do with it, right? So this is something that unfortunately happens. And, you know, these tend to be people, you know, in this case of coordinated attacks, they tend to do a lot of trolling and so on. So they're not really the most focused. So, you know, as soon as they see something, they will go and attack. That's.
Hi, Gianluca.
Yeah.
This is Bogdan Carbunar. Very interesting talk. Thank you very much for giving it. Just a quick question about the Zoom bombing.
Yeah.
So you mentioned that a lot of the attacks take place, they are initiated by insiders.
Yeah.
So how were you able to de-anonymize or figure out that these are insiders?
We did not de-anonymize them, but there were a number of indicators that we looked for in the threads. So it could be somebody mentioning, come disrupt my class, or, my teacher is live now, or language like that. But also the fact of having the password, or, providing information about names of real people in the class and so on. That's a giveaway that they are insiders. Of course they could be lying, but that's how we, that's the categorization we made.
Of course. Thank you.
Also, I should say that we only looked at attacks that are publicly called for on these platforms. So there may be outsiders who are just, trying to brute force meeting links or something like that. So we could not see that. But those would not be organized attacks or coordinated attacks, at least.
I see. All right, thank you.
Sure. Okay, so let me move to the second topic, which is disinformation propagation. So we need to answer the question, how does news propagate on the web? And the way news propagates, typically somebody sees a news article, let's say a New York Times article, and finds it interesting, posts it on Twitter, and then someone else maybe sees the tweet and posts it on Facebook. On the other hand, we might see some coordinated campaign trying to make some news go viral. And so we could have, once again, a coordinated group, let's say on 4chan, for example, posting something on Reddit, and then maybe legitimate users will post it on Twitter, or maybe there will be another coordinated effort to post it on Twitter. So there is a mix of legitimate sharing and coordinated influence campaigns, some of which are orchestrated by activists, some of which are orchestrated by state actors, and some of which are orchestrated by trolls, and so on and so forth. So can we actually model how these stories are discussed and shared on web communities? So for this kind of work, we use this model called Aux Processes. So the idea is, can we model whether a link, let's say, appearing on a social network is likely generating the same link appearing on another social network? So this model allows us to have multiple communities. Each community is a social network. And each community has a background rate, which is the probability that any event will appear on that platform organically. Just, I see something on New York Times and I post it on Twitter. Nobody prompted me to do that. But then every time an event happens, so somebody posts a link, this generates impulses on the same platform. So if you see something on Twitter, you're likely to retweet it, but also on other platforms. So that increases the probability that somebody will see that link and go and post it on Facebook or 4chan or Reddit. And this keeps going on. So if another event happens, then this impulse adds on top of the other one, and so on and so forth. And so what you can do once you see a link and you see the height of these waves, so to speak, to put it simple, you can kind of estimate what is the probability that that link appeared because somebody else posted it on another platform rather than it appeared organically. And the way we do this, we basically for each piece of information that we're looking for, in the basic case, the same news article, we fit a Aux model to our data. We estimate the parameters with Gibbs sampling. So we're estimating basically the height of the background rate, the shape of these impulses and how long they are, and so on and so forth. And then that allows us to tell us how likely is it that a certain community actually influenced discussion on another community, okay? And this is interesting because we can use this model to understand the influence dynamics of any type of online information that we can measure. So what we did, we built an analysis pipeline to measure how news stories are discussed. So we identified over 1,000 news websites we identified the discussion containing links to these news websites on a number of online platforms, 4chan, Twitter, Reddit, Gab. And then we did a number of things, including these Aux processes. In the first paper that we published, we look at single URLs and how do they propagate across different communities. And our results show us that these 5% of this low trustworthiness or alternative news, or call them as you like, we use NewsGuard, which is a news ranking website, to find this trustworthiness, that appear on Twitter. So 5% of the alternative news that appears on Twitter likely comes from either 4chan's politically incorrect board or the Donald subreddit, which was this polarized subreddit that was actually banned by Reddit sometime last year. But this was before that. And this is interesting because we can see that these communities that are very small, so we cannot really estimate how big 4chan is. But estimates, users there are probably in the order of hundreds of thousands or something like that. That has a disproportionate effect on a community with hundreds of millions of users. So these users are very focused and very good at what they do in making content go viral. And then in a follow-up project, instead of looking at single URLs, we group together URLs that talk about the same story. And we do that by using GDELT, which is a database used by journalists to figure out what events are discussed in news stories. There are events for each article, and we basically build a graph where each article has an edge to another article if they talk about the same event, and so on. So based on these news stories, we find that Reddit is actually the community that has the highest external influence overall. So news that are first shared on Reddit are more likely to go viral on other platforms. And within Reddit, we find that the Donald subreddit is the most efficient one. So, the number of news that they make go viral compared to the size of the community when it comes to news discussion in general. And we find that different communities make different kind of news spread. So we find that on Twitter, the news story in the immigration debate that went viral the most was, about travel bans and things like that. While on more polarized platforms like the Donald, we find that we see news articles and news stories that are somewhat misinterpreted. Okay, so this article said that migrants may have fueled violent crime rise. If you go and read the article, actually that's not what the article says, but this gets taken out of context and gets pushed on Twitter, on Reddit, and so on. Similar for 4chan, we see that Mexico agrees to pay for the wall, and this is actually a more unreputable kind of news. But we can see how within the same broad topic we can identify the different communities are actually pushing different narratives. And then we can apply the same techniques to state-sponsored disinformation. So what we do here, we analyze the data shared by Russian troll accounts and Iranian troll accounts on Twitter and Reddit, as identified by Twitter and Reddit as a follow-up investigation to the 2018 midterm election. And we find that, these accounts tend to portray fake personas and they tend to change their identity over time, which is kind of interesting. So we would see some of these accounts used to be active in Ukraine, posting in Russian or Ukrainian, and then they reset, they deleted all their tweets, and they became, a conservative newspaper from the Midwest or something like that. Or they assumed a US-based persona, and then they became active during the 2016 election, and so on. And we found that these troll accounts were actually able to push quite some content on Twitter, as well as Gab, as well as Reddit. So whatever they posted, some of it went viral. Now, a big question here is, did that matter, in the sense that we can only see the number of posts being shared, but did it change anybody's opinion? We cannot really tell that from a purely quantitative analysis. And then the next thing we did, we looked at image-based weaponized information. So weaponized information does not only cover text, but it also covers images, which are actually more immediate. And so, maybe people will be more enticed into sharing them or, looking at them and so on. And in particular, we focused on this branch of false information called photography from the French, which are visual images which convey either a questionable or a false sense of the events. So they are manipulated or miscaptioned images or whatever. Of course, determining if a picture is true or false may be difficult. So what we did, we looked at Snopes, the fact-checking website, and they have a database of which images are true, false, and whatnot. Each of them has a label. And then we took these images and we developed an analysis pipeline to identify social network posts containing these images, as well as news articles containing these images, so that then we can study how are they shared, how are they discussed, and so on and so forth. And we do this by using perceptual hashing. So perceptual hashing is a technique that given an image, it splits it in quadrants, and then it calculates a hash for each quadrant. And basically, two images that have a similar perceptual hashing are visually similar. Okay, that's the idea. And it's also resilient to manipulations to some extent. So it's not a regular hash where if you just re-encode the image, you will get a completely different hash. These images will be still produce a similar perceptual hash. And this is used by social networks to identify, illegal content or, child pornography and things like that. So, we adopted in this space. So we find tens of thousands of these instances. And what we find is that images that contain this photography get shared or liked more than other posts. Even posts containing other images. So if we have a post containing a photography image and a post containing a regular image, the one containing the photography image is more likely to get shared and liked. And this is somewhat matching previous findings that looked at text-based disinformation, showing that disinformation tends to get shared more, maybe because it's inflammatory or whatever. And then we find that moderation is tricky because these images can be modified, taken out of context, used as jokes or all sorts of things. So we see in the first one, that was a real picture of a senator abusing a female soldier. But then we see that this got modified in all sorts of ways. So, different people were photoshopped in it, or it was just used as a joke or whatever. So what do we do about these images? If we were just deleting them all, we would have a lot of false positives and so on. So we need to think about that. Then we went back and looked at these troll accounts, and we looked at the images that they're sharing. And we found a number of things, but basically they were using images as political disinformation during the 2016 election and beyond. And we found that 6% of the images that they posted actually did go viral on Twitter. So this gives us some feeling of how effective there may have been. Finally, there is a big question on what to do about all these accounts. So if you're talking about fake accounts, the troll accounts and whatnot, it's easy to suspend them. But if you think about real people, maybe influencers posting disinformation or being abusive, the natural reaction is to suspend them, but we do not understand very well whether this could have side effects. So people could move to more extreme communities, maybe communities that do not have moderation. And what happens next? Do they get exposed to more extreme views? Do they maybe become radicalized? Do they maybe become radicalized even in real life? Maybe go and commit some acts of violence. Do they become more toxic? Do they come back? Maybe they gather on one of these unmoderated communities and they organize attacks against their old community. This is something that's not well understood yet. We have some work in progress that seems to suggest that once a community gets banned on Reddit, we looked at the Donald and we looked at incels, and they create their own service, their own forum outside the platform, the number of people who remain active on the new platform shrinks, maybe because they're not as committed. They would rather be on a platform where they can talk about all sorts of topics. But those who make the move actually become more active and they become more toxic. And we use some, NLP APIs to find, increase in hate speech and all these kind of things. So it's not clear how that will influence their activity later on. This is something that we should be studying more. So to conclude, I showed you that weaponized information spans multiple services, multiple media, and we need techniques able to take this into account, to identify these flows of information, identify influence across platforms, and ideally reason about not only text, but also other types of content. And, as a food for thought, we need better mitigations. So we need to think whether banning accounts is the right solution. We need to think whether deployed mitigations reflect actual attacks. So think about the Zoom bombing case, where an external attacker is assumed, but actually turns out that insiders play a big role in that. And I should say, I just saw an article that Zoom is introducing feedback mechanisms where users can actually flag abusive users in their meetings and things like that. So that's maybe a step in the right direction. We'll see. And also we need to think that moderation measures need to be context sensitive. So something that might be hateful in a certain context may then be modified. Think about the images and lose that context. And if we apply a blanket policy for moderation, we end up deleting everything, and that might not be the best solution. And with this, I thank you, and I'm open to questions.
Hey, thanks, Gianluca, for the wonderful talk.